Hello everyone, my name is João Victor Bolson Marques, and today I'm here to present to you our study named Development of a Solution for Identifying Moral Harassment in Ubiquitous Conversational Data. So first of all, I'm going to give you a small introduction about the subject, then I'm going to talk a little bit about the methodology, and then the development itself. To finish the presentation with the conclusions and with questions, of course. The evolution of connective technologies has transformed how ubiquitous devices are used in daily life. So basically, you will have a smartphone in the palm of the hands of everyone, and everyone is having a conversation, which can be in person or virtual, of course. So ubiquitous computing integrates that technology seamlessly into human activities, make it nearly invisible to users. So basically, the phone is not there, but it is. Ubiquitous computing, of course, an emphasis on natural, seamless integration of technology in daily activities and interactions. Um, so the problem statement of our research is the increasing presence of ubiquitous devices that enables real-time monitoring of interactions. So basically, when you are in a job conversational uh, or in a university or maybe I don't know with some friend, uh, it's important to you to know that your smartphone could be there to help you and to assist you in a case of a moral harassment. So, however, there are gaps in detecting harmful behaviors, such as moral harassment in workplace and educational environments. Um, and the moral harassments basically consists of abuse, repetitive behaviors that compromise an individual's psychological, social, and professional well-being. Um, and lastly, advanced AI modules can help detect such behaviors by analyzing conversational data. The main objectives of our study is to develop an AI-powered system to detect moral harassment in conversational environments. So you use natural language processing and machine learning techniques to identify harassment patterns in recorded audios. We also provide a mobile app and user-centric solution for monitoring and reporting inappropriate behaviors. So now a little bit about our methodology. We have a practical approach on this study. We applied methodology focused on human-computer interaction and user-centered design. Um, the mobile app enables audio capture in ubiquitous environments, and the backend is responsible for processing and analyzing captured data using AI and natural language processing. So about our stack, for the mobile app, we use it Reactive Native and Expo, which is a TypeScript framework that allows you to create native apps. For the backend, we use Nest.js, Prisma, and PostgreSQL, and a fast API as well. I'm sorry. And for the audio transcription, you use it Whisper, which is an open API framework that ensures accurate conversion from speech to text. So a little bit about the detection pipeline. Um, we use it for detection process here. The first one is the SQL match, which exact matches with non-offensive phrases. So basically, we have a shared database that can match user inputs with known cases about offensive phrases. Similarity checks that compares user-flagged examples, AI modules, contextual analysis using Mistral and Cohere, and user voting. that empowers users to validate ambiguous cases, such as cultural or slang phrases. And the results are stored and made visible to users. So a little bit about architecture. We have designed a modular system that handles audio capture, transcription, and analysis. There are interactions between the front end, which is the mobile app, the API, and the database, of course. So basically, is just like that the figure example here. Uh, about the recording and the detection screen. So the app offers a simple interface for recording audio in real time. After recording, users can trigger the detection process. Um, so the detection process is not in real time. The detection process is done after the recording. It's important to mention that. The results from the four detection strategies, as I said before, are displayed clearly into another user screen. And this encourages user transparency and participation. Now I'm going to show you a little example about the detection screen. So on the left side, we have a no moral harassment detected. And on the right side, we have a moral harassment detected here. So here is the last detections. And if the user wants, he can start another recording here. So about the detection modules. So as I said before, we have four ones, SQL match, similarity check, Mistral AI, and Cohere AI. And a final report summarize and combine the results. So basically, this is the detection process, and then we have the detection modules that analyzes this recorded audio, and here we have the detection report. So basically, as I said before, we have this first screen here, and then we have the reports. So here we have the four reports here, the Mistral AI, Cohere, the database, and similarity check. Also in the database, users are allowed to insert more known cases in the database. That is a shared database, and this phrase here can be voted later for others users, and that can allow the system to improve itself in the future. So about the user feedback and learning. The system uses two types of detection results. So there is one AI-based and database-based. So the first one are fixed. They are from Mistral and Cohere. So the results are fixed and cannot be altered by users. So there are no changes allowed. And the database-based results can be refined, as I said before. Users can vote on whether the phrase should be flagged as an harassment. And this feedback, of course, helps improve the database and guides futures detection. And the system combines the two automation, the two process here, the automation with human insights to adapt culturally and contextually. Because to one culture, one phrase can be a moral harassment, and to another, it can't. So about the user voting screen, here the user can vote for uh, the user can vote if that phrase represents a moral harassment for him. And about the testing scenarios now. So a variety of phrases were tested to evaluate the system. So the first one was we used offensive phrases like "you are useless," so that represents direct harassment. We used also neutral phrases like phrases that are present in everyday conversation, non-threatening phrases. And of course, we use it hierarchical phrases like phrases that are employ that phrases that are present in interactions between boss and employees. And the last one, you use it regional and colloquial phrases. That means slang or culturally specific expressions. These tests expose divergences among detection methods and reinforce the importance of a hybrid, multi-layered detection strategies. We can't count only with AI. We have to do. We have to have uh, a user voting scheme that allows the system grow itself in the future. Um, and about the conclusions now. So this work demonstrated the feasibility of detecting moral harassment using a hybrid architecture, combining traditional techniques with modern AI modules, enhanced accuracy and contextual understanding. So Ubiquitous mobile computing provided effective in capturing real-world informal conversations, and the approach shows how technology can contribute to safer and more ethical environments. So about the key contributions, we implemented we have a practical implementation of a moral harassment detection system using a modular and extensible architecture. Um, the evaluation used two different modules, which included Mistral and Cohere, and the creation of a user-curated database that involves overtime through interaction. And lastly, the real-time feedback loop enabling system learning and adaptability. About the challenges, uh, we have processing delays currently. We know that long conversation requires high computational resources for transcription and analysis, and that is currently a problem in our research. About the privacy and ethics, we know that an app recording your conversations can be very very invasive. So we have concerns about the privacy and ethics about the launch of this app, and we are studying approaches on how to handle that. And about the scalability. So the database-based detection approaches become slower as the number of stored phrases grows. Um, and that requires smart indexing and optimization strategies. So these three topics here is our main challenges today. And about the future works, we're expecting to integrate with more pervasive computing devices like televisions or smart devices. Um, Improving AI model adaptability and response time, and conduct studies for validation with users. So thank you all for the invitation, and I'll have I'll I'll leave here some space for questions. So thank you. Bye.